In this video, we're going to learn about the derivative of the natural logarithm, ln(x). And in order for us to really understand this derivative, we need to review implicit differentiation. We need to do implicit differentiation with respect to a variable. And in this case, we'll be doing it with respect to x. When doing implicit differentiation with respect to x, the key idea is we want to think of the variable y as a function of x. In other words, when we take the derivative of y, we write that derivative as dy dx. That represents the derivative of a function that we have defined implicitly. So for example, if we have some function, y represents some function, and when we want to find the derivative of that, we need to use the chain rule. So in this particular case, you would have to take the derivative of the outside. The outside function, is f of x equal to x cubed, and the inside function is y, right? So then when you take the derivative of this, the derivative of the outside is 3 times something squared. You keep the inside function y, and then you multiply by the derivative of the inside, which is dy dx. So that's an example using the chain rule. Let's take a look at another example. Let's say you have something that looks like this. This guy right here requires you to use the product rule, right? So, one function would be like x squared, and the other function would be y. So when we take the derivative of this, we need to use the product rule. Okay, so let's do that. So the derivative of the x squared is going to be 2x, and then you keep the second function, the y, plus, now we're going to take the derivative of the second function. The derivative of y is dy dx. And you got to multiply by the first function, x squared. Let's take a look at another example. Let's say we wanted to differentiate sine of y. In order to do that, we would need to use the chain rule again. The derivative of the outside function sine is cosine. We keep the inside function y. Then we got to multiply by the derivative of the inside function. Okay. So now that we've reviewed the implicit differentiation, we're finally ready to talk about the derivative of natural log of x, which is what this video is really about. So let me tell you what the actual answer is. So I'm going to write the differentiation operator, and we're differentiating natural log of x, and that's equal to 1 over x. Let's look at the proof. We start with y equal to natural log of x, and then the next thing I want to do is I'm going to raise both sides by e. So I have e to the y is equal to e to the natural log of x. And then if you look, e to the natural log of x, these two functions are inverses of each other, right? That means that they have a cancellation property, and we apply that property, and we end up with e to the y is equal to just x. Now, why did we do all of that implicit differentiation review earlier? Well, we want to do it now. So we're going to differentiate both sides of this equation with respect to x. Okay, so we use the chain rule to differentiate the left-hand side. the derivative of the outside function e to the something is just e to the something. You keep the inside and you multiply by the derivative of the inside. In this case, the derivative of the inside is just dy dx. When we differentiate the right-hand side, the derivative of x is just 1. Okay, so we can solve for dy dx. Dy dx is just 1 over e to the y. But what was e to the y? Remember, y was equal to natural log of x. So we have a natural log of x here. And just like before, we could use this cancellation property. So when we apply the cancellation property, we end up with 1 over x. So in the end, we end up with dy dx is equal to 1 over x. And that proves what we're trying to show. All right, everybody, take care.